This math talk is just a follow-up to the last math talk we did on rational numbers or fractions. And in the last math talk, we looked at adding and subtracting fractions with the same denominator. And so we sort of left it off saying, well, what will we do if the denominators were not the same? In other words, they were not equal. In this case, we have the question, evaluate 1 over 4 plus 1 over 3. So in other words, a quarter plus a third. To give us an idea of what this really means, I want to start with a visual. So we'll start with a circle and divide it into 4 equal parts. 1/4 of that circle would represent one of those parts shaded. Now to that we're trying to add 1/3. So we take a second circle and we divide it into 3 equal parts. And again, we shade one part of that circle. So that's 1/3. So the question becomes, how do we add a quarter to a third? And I would say to you, could it be something as simple as 2 over 7? In other words, would I just add the two numerators, 1 plus 1 to get 2, and the two denominators to get 4 plus 3 or 7? Could it be 2 over 7? And the only reason why I bring this up, because this answer is actually incorrect, I bring it up because it's a very, very common error that students make. And I want to show you really why it doesn't work. So let's take a look at a circle and we'll create 7 divisions in it, or 7 equal slices. Now what I'm going to do is take that 1/3 region and that 1/4 region and place them on that circle. Well, you can see already that the orange region alone shades more than 2 parts out of the 7. And once you add on the red region, you have over 3, possibly greater than 4 when you put all the pieces together. So what's immediately obvious is that this couldn't possibly be the correct answer. So we've got to throw all notions of that away, any idea of just adding numerators and denominators. So the question becomes again, well, what exactly is 1/4 plus 1/3? So looking at the region shaded, we could say, okay, suppose we superimposed our quarter grid on there. Well, we can see that the answer lies somewhere between 2/4. 2/4 are fully shaded plus a little bit more. So it's somewhere between 2/4 and 3/4. So we're not going to measure it in quarters because it's between 2 and 3. Well, if we did the same thing with the third grid, we could see that the answer lies somewhere between 1/3 and 2/3. Again, thirds won't work for us. So what are we going to do? Well, what we need to consider is re-slicing our circle. And so when I say re-slicing, what I'm going to do is recognize that one circle is sliced in 4, the other circle is sliced in 3. So it might not be a bad idea to slice it in smaller slices, or in other words, 4 times 3 or 12 slices. So I'll take that first circle and divide it into 12 regions now. I've still got the same red region shaded, but you can see that my 1/4 is the same as 3/12. It's the same region of the circle, but it's written as 3 over 12. And we talked about this earlier, about equivalent fractions in an earlier video. So 1 over 4 is equivalent to 3 over 12. Well, I can place that same 12 slice grid on top of the second circle, and I can see that 1/3 represents 4 of the 12 slices. When we have matching denominators, it becomes a simple task to add the two fractions of adding the two numerators. So we have 3 red slices, 4 orange slices. So our result will be 7 out of 12, or 7/12. Let's try that again. So looking at 3/4 plus 1/6. Once again, I'm going to illustrate this with a diagram. I'm not going to do this every time, but for the first couple of times I'm going to, just so that you have the visual representation of what we're talking about. So 3/4 looks something like this. 4 equal sections of which I shade 3 of the 4. And the 1/6, same sort of idea, but I have 6 equal sections of which I shade 1. So that's going to be equivalent to a region that is made up of the 3/4 and the 1/6. Once again, we're trying to create the same sort of slicing. So when I look at this, I say, okay, how could I make the two denominators the same? So the 4 and the 6, we need to do the same slicing so that the denominators are the same. Well, once again, I look at this and I say I could impose that 12 slice grid on the 3/4, and 3/4 would be equivalent to 9 over 12. And I look at the second circle and say I can place that same 12 slice grid on top of that. And so my 1 out of 6, or 1/6, becomes 2/12. Once again, I now have two matching denominators. So the combined region is simply the 9 over 12 added to the 2 over 12. I leave the denominator alone, and the numerator is 11 out of 12, the 9 plus the 2. Let's try one more with a diagram. Okay, 3 over 7 plus 2 over 5, 3/7 plus 2/5. I'm going to change the shape of the figure that I'm going to work with. I'll work with a rectangle in this case. And so the 3/7 is a rectangle divided into 7 equal bars, of which I would shade 3. The 2/5, I could take the same rectangle and I'll slice it vertically into 5 equal bars. And then I will take 2 of those. You can see from the diagram that the orange bars are different from the blue bars, so we can't just simply add those together. What I want to do now is slice the rectangles so the regions are the same. So that means increasing the number of slices in each rectangle. So the easiest way to do that is to take the left-hand rectangle and slice it the way I sliced the right-hand rectangle. Let me show you what I mean. So I'm doing the same vertical slices, so now I don't have 7 regions, I actually have 35 little rectangles. Well, if I do the same to the right-hand rectangle, slice it horizontally, I also have 35 little rectangles. Now all my regions are equivalent. And so the left-hand rectangle, instead of being 3/7, is now, out of 35, 15. So we have 15 35ths. Similarly, on the right-hand rectangle, we have, again, it's sliced into 35, of which I have 2 columns of 7, or 14 regions. Now that I have both rectangles sliced the same way, and I have 2 denominators that match, the addition is simple. If you can picture, I've got a rectangle with 35 slices. I'll fill in my blue rectangles. I'll fill in 15 of those orange rectangles, and now I have the total region, or the total combined, of the 2 left-hand rectangles. And so I have a total of 15 plus 14, or 29 35ths. So I want to generalize what we've done in each of these examples. We've said when adding or subtracting fractions with different denominators, our first objective is to get the denominators the same. In other words, we're trying to rewrite each fraction with a common denominator. So in this example, we had a denominator of 7, a denominator of 5. We were trying to create a common denominator, and that was 35, the 5 times the 7. Once you have the denominators the same, you can just simply add or subtract the numerators, and your question is finished. Now, you may say to yourself, how do I get that common denominator? Well, I would say to you this. Your lowest common denominator, or the common denominator you want to use, is the same as the least common multiple, something that we talked about in a couple videos back. So you're trying to find the least common multiple of 7 and 5, and that would be 35. That became our lowest common denominator. Let's do some without diagrams. Consider these. 4 over 9 plus 1 over 2. So 4/9 plus 1/2. So our first goal is to figure out what is the lowest common denominator. Well, I start by looking at the 9 and I say it's simply 3 times 3. I look at the 2 and it's prime, so it's 2. My lowest common denominator would be the 3 times the 3 times that 2, or in other words, 18. So here's what I do. I take a look at my 9 and I say, how do I turn it into 18? Well, I do that by multiplying by 2. If I've done it to the denominator, I must do it to the numerator to keep the fraction equivalent. So I multiply the numerator by 2, leading to 8. So 4 over 9 is the same as 8 over 18. Moving on to the 1/2, we're trying to convert its denominator also to 18. So when we look at that, we say 2 turns into 18 through a multiplication of 9. Well, we do the same to the numerator, and 1 times 9 becomes 9. Now we have 2 fractions with the same denominator. The denominator stays as it is, just an 18, and the numerator is the 8 plus the 9, or 17. So we have 17 over 18. Let's try another. We've got 7 over 8 subtract 5 over 6. Now, it would be tempting to go to a common denominator of 8 times 6, or 48, but you'll see that there's actually a lower common denominator. And let's see how we get it. We look at 8, factored, it's 2 times 2 times 2. We look at 6, factored, it's 2 times 3. Now the lowest common denominator, I said before, is going to be the least common multiple, and from our earlier videos, we know that that would be the 2 times the 2 times the 2 from the 8, plus the additional 3 from the 6. And so 24 is our lowest common denominator. It's divisible by both 8 and 6. So we're going to convert denominators to 24 now. In the case of the 8, that means I have to multiply it by 3. I must do the same to the numerator. So the numerator becomes 21. With the 6, to convert that to 24, I multiply by 4. And with the 5, I do the same, and it becomes 20. Now my denominators match. I simply leave the denominators alone and subtract the numerators. 21 subtract 20 is 1, and we get 1 over 24. Let's do 2 more. So we have 11 over 12 plus 3 over 4. Well, 12 is 2 times 2 times 3, and 4 is 2 times 2. Well, our lowest common denominator then is just the 2 times 2 times 3. In other words, 12. And you can check that. 12 is a multiple of itself, and 12 is a multiple of 4. So we're going to convert all denominators to 12. Really, it's trivial on the first one, because that would be a multiplication of 1. So it doesn't change anything, and the 11 doesn't change either. It stays as 11. Whereas when we get to the 4, we would have to multiply the 4 by 3 to turn it into 12. So we do the same to the numerator, and it turns into 9. Now, adding the fractions, we leave the denominator alone, we add the numerators, and we get 20 over 12. Recognizing that 20 divides by 4 and 12 divides by 4, we do that, and we get 5 over 3. And if you want to go to a mixed number, it is 1 2/3. One last one. 3 1/2 subtract 1 2/3. I'm going to begin by converting these to improper fractions. Now I want to tell you that's not the only way to do it, but for today's video, that's what I'm going to do. So the 3 1/2 is equivalent to 7 over 2. And the 1 2/3 is equivalent to 5/3. So now looking at the two denominators, this is going to be really easy. One denominator is 2, the second denominator is 3. They're both prime numbers, so my lowest common denominator is simply 2 times 3, or 6. So converting the first fraction to a denominator of 6, we've multiplied the bottom by 3, we multiplied the top by 3, making it 21. With the second fraction, we multiply the 3 by 2 to make it 6, so we multiply the top by 2 to give us 10. Our denominators now match. 21 subtract 10 is 11 over 6, and if we want to convert that to a mixed number, it is simply 1 5/6. That should be plenty to get you started on adding and subtracting fractions with unlike denominators or different denominators. It's all about finding that lowest common denominator. The lowest common denominator is always the least common multiple between the two denominators. Do lots and lots of questions. As you do more and more, these become second nature. Thanks for watching.